There we go. I'll try to record this and send it to you guys later. Okay? All right. So which of the trig ratios then, which trig ratio are we going to be able to use to get to those two? Well, John said tangent, so I'm assuming John's looking for opposite first, which is totally fine. So what we do is we pick the side that we want to try to find and pair it up with the side that we know the length of. So we pair up opposite and adjacent, and that leads us to using the tangent. So it'd be the tangent of 63 is equal to the opposite side divided by the adjacent. The opposite side is t, and the adjacent side is 120. Again, we need that value, so we use our calculator for the tangent of 63, which would be 1.96. We think of it as being a fraction by putting it on top of 1 and cross multiply. So 1 times t, and then 1.96 times 120.
Equals 235.2.
Well done. So that would make our tower 235.2 feet tall. That would make the tower 235.2 feet tall. Okay? And if we wanted to find the length of the wire, how much wire is required to go from this mooring point to the top of the tower, that wire is the hypotenuse. And if we continue to use the side that we know the length of, adjacent, when you put adjacent and hypotenuse together, that leads you to using cosine. Because cosine is equal to the adjacent side divided by the hypotenuse. The adjacent side is 120. The hypotenuse is the W, the wire. That would be required. Again, we can solve that. We need the cosine of 63, which is 0.45. We cross multiply. And we divide both sides by 0.45. So 120 divided by 0.45 is 266.7 feet of wire. So we could tell both the height of the tower and how much wire is required to moor it, at least in one direction, without ever climbing it. All right, that looking okay with everybody? All right. So again, that's the idea, right, is to be able to label the sides opposite, adjacent, hypotenuse, and then look at which one you're given the length of, and then figure out which one you want to find, and then which ratio does that lead you to. Okay? So I've got one more phrase then that I wanted to mention to everybody. One more phrase. And that is when you're looking down at something. When you look up, it's called angle of elevation. We have a different phrase when you're looking down. So a problem where we're going to be in an airplane. Exactly. Well, if you're hanging out the front of the plane, you probably should have a little caffeine in you. Okay, so we're flying a plane. We hopefully aren't going too far because we're hanging out outside. We opened up the window. All right. And off in the distance, guys, we see a town. All right, so we see some buildings. All right. And what we do is from level, right? If I was looking level, to see the town, I would have to look down. So when we look down towards the town, we then call that, instead of an angle of elevation, that's when we look up at something. When we look down, it's called an angle of depression. When we look down at something, it's called an angle of depression. Okay, and let's just make up a problem here. Let's say that the pilot has to look down at 8 degrees. Let's say the pilot looks down at 8 degrees. The pilot, because of the gauges in the plane, knows that he or she is flying at 12,000 feet. Question, can we determine both the horizontal distance the plane is away from the town and the straight line distance that the plane is away from the town? Can we calculate those two distances? Okay? Horizontally, how much farther does the plane have to go? Or if the plane just tipped over and started going this way directly at the town, what would be that distance? Could we calculate both of those? And the answer is right now, no. Because inside the triangle that we formed by the plane's altitude, the ground, and then the imaginary line that connects the town with the pilot's eye, with that made-up triangle, do we know another angle other than the 90? Inside of the triangle, do we know an angle other than the 90? Not inside. We do know this one outside, but not inside. So the question is, and I think you guys will be okay with this, if we know this angle is 8, what's this angle? 8. And why is that going to be 8? Because when we were looking out level, a level line with your eye, even when you're flying, is going to be parallel to ground level. Would you agree? So therefore, your eye level in the plane and ground level are parallel to each other. Therefore, this angle and this angle are going to be equal because they are nice. Opposite or alternate interior angles. Good job. Good job. Doesn't matter. Opposite means the same thing, so good. Good. Now are we in good shape? Yeah, because now we have another angle inside of the triangle. Now we're in good shape. Okay? And now we can label the sides using 8 as our angle across from the 90-degree angle, hypotenuse. Directly across from the angle that we circled, opposite. And then the side that makes up the angle that's not the hypotenuse is the adjacent. And again, can we find those two missing pieces? Yes. Yes, we can. Okay? And I forgot who said it before. I'm just going to choose to use trig on both of them for practice, even though I know you guys could use Pythagorean theorem once we get to. But I'm just going to use trig on both of these. Okay. So since the side that we know is the opposite, and let's say I want to find the adjacent first, when I put opposite and adjacent together and check my definitions, which ratio involves opposite and adjacent?
The tangent.
Tangent. Well done. So that's the trick. What am I given for a length? Which one do I want to find first? And then put those two sides together. Which ratio does it match up to? It's only going to match up to 1. Only going to match up to 1. So it's going to be the tangent of our angle, and tangent's equal to the opposite divided by the adjacent. The opposite is 12,000, and the adjacent is h. So we solve. We need the tangent of 8 degrees. Oh, need to turn on a calculator first, I guess. And that would be about 0.14. So we think of that as a fraction so that we can cross multiply. So multiply this way, 0.14 times h Cross multiply this way, 1 times 12,000. And when I divide both sides by 0.14, the horizontal distance then is going to be 12,000 divided by 0.14. And what we get is approximately 85,714. 85,714. So that's how many feet horizontally we are away from the town. Okay? And then when we make the switch and want to find the straight line distance from the pilot to the town, now we're looking to find the hypotenuse, and we know the opposite. Hypotenuse and opposite, when you pair those together, opposite and hypotenuse leads you to using the sine. So the sine of 8 degrees is then going to be opposite divided by hypotenuse. Opposite, 12,000, hypotenuse, d. Again, we need the trig value, so the sine, oops, sorry, hit the wrong button. The sine of 8 degrees is 0.13.
But there's 9 after the 3, so will not be avoided.
And again, cross multiply. So when we divide both sides by 0.13, we get about. We're doing some rounding here, of course. We get approximately 92,307. All right, so that's the idea. That's the idea of being able to find, missing pieces of triangles when we know an angle. When we know an angle, right? So it's trig, it's sines and cosines and tangents that help you connect angles of a triangle to sides of a triangle. Instead of just working with angles only or sides only, bye-bye. Trig allows us to